The last example in lesson 8.4, day 1. What is the product of x plus 2 divided by x to the fourth minus 16 and x cubed plus 4x squared minus 12x? We know product means to multiply. So the first step, we're going to take x plus 2 over x to the fourth minus 16 times that second term. If it's not a fraction, but we need to make it a fraction, we're just going to put it over 1. So x cubed plus 4x squared minus 12x over 1. All right, now we need to factor. In the first fraction, we have x plus 2. In that denominator, this one gets a little tricky. We have x to the fourth minus 16. Technically, x to the fourth is a perfect square, so that can be rewritten as x squared plus x squared. So you can write that in there. And 16 is a perfect square, 4 and 4. And remember, one sign is plus and one sign is minus. Now that seems all fine and good. However, x squared plus 4 is kind of stuck for factoring, but x squared minus 4 can be broken down even further. They're both a difference of perfect squares again. So that would give us x plus 2 and x minus 2. Okay, so let's go to the next one. In that second fraction, we have x cubed plus 4x squared minus 12x. I notice that all three terms have a common factor. I'm going to take that x out first. And that gives us x squared plus 4x minus 12. All over 1. And that x squared plus 4x minus 12. Let's think of two numbers that multiply to get 12, but add to get positive 4. That would be 6 and 2. But to get positive 4 when you add and negative 12 when you multiply, the 6 needs to be positive and the 4 should be negative. So let's see where we're at. I'm going to just rewrite this whole thing with that information. So we have x plus 2, and I'm going to put that in parentheses, divided by x squared plus 4, x plus 2, and x minus 2. This is, I don't know if I have enough room. All right, so for the second fraction, we have the x on the outside. So remember I said take the x squared, we'll split that up into x and x. Two numbers that multiply to get negative 12, add to get 4, plus 6, and minus 2. All over 1. Okay, so there's step 1. Luckily, we don't have a lot left. Step 2, for our denominators, we have x squared plus 4, x plus 2, and x minus 2. And remember, by definition, they can't equal 0. Well, for that first fraction, if we try to solve x squared plus 4 can't equal 0, and we move 4 over, what ends up happening is we try to take the square root of a negative number. And that's not a real solution, therefore it wouldn't be a domain restriction. So we don't have to worry about anything there. But the x plus 2 can't equal 0. Will give us a restriction. Our first restriction will be x can't equal negative 2. And then for the other one, if x minus 2 can't equal 0, and we now add 2 to move it over, the other restriction is x can't equal positive 2. So for these fractions to work, those two numbers are invalid for x. All right, step 3. I need a different color here. I'll go back to purple. For step 3, I'm just going to cancel, so step 2 was right here. Oh yeah, okay, step 3. Anything we can cancel on top and bottom in this group right here. Well, right away in that first fraction, I see an x plus 2 on the top and the bottom. And then in the second fraction, there's x minus 2 and x minus 2. And I think that's all we get. For our final answer then, in the numerator, we have x times x plus 6 all over x squared plus 4. And the x squared doesn't break down with the two x's on the top, and the 4 and the 6 won't reduce. Remember, anything with addition or subtraction has to go as a group. And that's that last example for 8.4, day 1.